everybody. My name is Marco. I am developer advocate. I work at Ripple. I will explain what the company does. But the goal of this workshop is to learn the basics of blockchain, to understand like what is the problem that it's trying to solve, and what are the technologies underneath that are the principles that you would probably need to think about when you're trying to come up with solutions that leverage blockchain technology. So the goal of this workshop is to try to prototype a business or an idea to kind of like work towards implementing something that solves a problem in the real world. So I think to start with, I think it's good to have a session with also including a conversation and brainstorming about what are like the things that people are doing with blockchains. What is all of this noise about? So we're planning this session to be like the 101 and very basics, but then the other sessions we will learn a little bit more about what people are doing with assets like NFTs or fungible assets, stable coins, and other things that are like famous for different reasons. And the third session will cover things related to finance and decentralized finance, DeFi. It's a big area, also with a lot of attention and a lot of like possibilities and money flowing into it. And the goal is to give you an overview of what can be done in this like new decentralized finance world. This one. What we will be covering today is like we will be talking about blockchain, but we will be focusing on XRP Ledger as a blockchain where you will be able to prototype things, to interact with. So we will go a little bit deep into what that ledger offers and how is it structured. We will, after that, I'll speak more about like technicalities, and then we will like explain like how transactions work, and so what are transactions, how to interact with a blockchain, and then I'll talk more about other like surrounding technology around like XRP Ledger, where you will be able to see how it interacts with other blockchains. And at the end of the session, we will be brainstorming, exchanging ideas, and having like just general questions. So that's kind of like the agenda for today. But feel free to interrupt me if you have questions, or if some of the things that I'm presenting, like they're not clear. So I think we have a small group in purpose so that everyone can like express themselves like freely, and hopefully we have answers to your questions. So don't be shy. So like XRP Ledger, it's one of many blockchains. It's one of the oldest chains. So it launched in 2012, and kind of like the idea behind this particular project was to address like the limitations of at the time. The only thing out there in crypto land was Bitcoin, and people, I mean, in 2009 was when Bitcoin like started as a project, and so it's not too long ago. And just like a few years later, like the idea of XRP Ledger was to cover those areas where Bitcoin was not shining or was not fulfilling like certain needs, especially in the financial world. And that's kind of like the motivation behind this particular blockchain. I'll explain more what are the differences, but just keep in mind that this is kind of like the point in time where these technologies started to emerge. So we're dealing with, honestly, a very, very new technology in a way. So a lot of the things don't feel fully baked. A lot of the people are still, I mean, blockchain is famous to be like a solution trying to find a problem. So like that's how people sometimes describe blockchain. And well, it's still yet to see what are the things that will kind of like fulfill the promise of the technology. A few things that I will be mentioning so that to not create confusion, let's just talk about like the different terms that I'll be using, because they're different parts of sometimes related things. The XRP Ledger is a blockchain. They call it layer 1 or L1 because there are like there's a stack right now in the blockchain world, and some people are building layer 2s. That means that those layer 2s are taking advantage of other blockchains underneath, which are the L1s. So XRP Ledger is an L1 blockchain, and that's what it's an open source project. So it's an open source project that people go to GitHub, they copy or fork the code, and then they run it in their like own infrastructure. And what it happens, this is any blockchain does the same thing. And by running this code, essentially they're participate in this like peer-to-peer network, right? So it's a protocol where like communication happens among these different computers that they're all like running the same code. And the code essentially is just like a protocol where like these computers essentially are validating as a group a bunch of transactions that any user like it's sending to the blockchain through like different ports of entry. So that's in general like high level concept of what a blockchain is and what the open source code that enables it. It's typically everything is it's public, right? So this is the case for XRP Ledger, but this is the case for Ethereum, and this is the case for Bitcoin. So there's a GitHub, you will see all of the code, and so it's auditable. The other thing that I'll be talking about is the XRP, which is it's the asset itself that the XRP Ledger enables. So essentially, when you have a blockchain, one of the things that I mean, Bitcoin started with this idea was the idea to move money around, but instead of like using the existing like fiat currencies like the dollar and the euro, so the idea was to create a protocol where you have a native form of money that only exists in that network, so that you can have like, it's not today in the world, you cannot know how many dollars exist. That's insane, but no one knows that number. So like it's kind of like works in a very different way, but with cryptocurrencies, like you have a full auditability and traceability of every token. So that's kind of like the principle that Bitcoin was built upon, and the goal of these native currencies like has evolved over time. So in the case of Bitcoin, it's the main purpose of the blockchain is just to have this unit of account, which is the Bitcoin unit that people transfer among each other in a peer-to-peer fashion. That means that without an intermediary, and that's kind of like the goal of the blockchain. However, other blockchains like Ethereum, they have a native currency like ETH, but they have other purposes. For example, in the case of Ethereum, you use that native token to pay for computation. So they have a utility in a way that it serves, it kind of like serves a purpose. And the same thing goes for the XRP. So the XRP is, it's a currency that it's used to pay for transactions in the XRP ledger. And why that is important is because, in a way, it prevents people from spamming the network. So if you have a network like this, you cannot make it free to make transactions, because otherwise people would, for free, just like DDoS, like denial of a service, attack the network. Meaning that if it's free, so it's like what happens with email, right? So email, essentially anyone can send emails for free because they have no cost. So that's why we have a bunch of spam. And the same thing goes for the blockchains. So the idea of having these native tokens, it's so that it actually has a cost. The interesting thing is that the mechanism behind Bitcoin, which is called proof of work, was actually conceived not for Bitcoin, but was actually conceived as a solution for email, so like email spamming. So the idea behind that is to create an artificial cost to do something that it's virtual, that it's digital, so that by creating that barrier, so it doesn't matter if you have to do something. In the case of proof of work, it's computation. So think of like, okay, I'm gonna do some complex computations, so I'm gonna like pay with the electricity in my machine time, and that's it. It doesn't matter if you're sending only one email, but if you're sending like hundreds of thousands of emails, then like the cost of the computation goes up to a point where like it makes it infeasible then at some point to send like hundreds of thousands of emails. So that's kind of like to see how out of these tokens you can create some form of utility. And the other term, it's Ripple. Ripple is a company like any other company. That's a company I work for. And the thing is that people confuse sometimes this. That's why I have this slide. Some people ask me, hey, so I bought some Ripples, thinking that kind of like that's the name of the currency. And the confusion comes from the fact that, in the beginning, people were like mixing the terms. Now it's very well defined, but in the very beginning, 2012, like people didn't fully understand which was the company, which was the token, and people were using like the terms. Today, it's kind of like easier to realize what that is, but it's a company and it contributes. So it hires engineers with the purpose of improving the XRP Ledger. That means that there's a group of engineers that they only are kind of like looking for ways to improve this layer one blockchain. The same way that other companies, for example, are hiring people and engineers to improve like the Bitcoin code base. That's how like you can be an independent contributor, but you can also be like working for these companies. If you're not like, if you kind of like want some normal structure and a normal job. So that's those are the terms that I think it's pretty clear, but I didn't want to skip that part. Just a few like just statistics. This is a decentralized blockchain that there's almost 2,000 applications that have been built. That goes from people like building exchanges and building like payment applications and things like that, things that use the XRP, for example, people that, for example, want to just index the transactions and provide like a way to navigate and make like user-friendly, like all of these bunch of things that happen in the peer-to-peer network. There are more than almost 5 million people that have wallets with XRP. So it's a huge community. We have a big community, for example, in Korea. We have a big community in Japan. We have a big community almost in every country, but there are like certain parts of the world where people are excited about about this first like cryptocurrency that was like super fast compared to like the existing options that at the time were there. There have been more than 2.6 billion transactions that have gone through the network, and there's more than $35 billion worth of market capitalization, which is essentially like the number of XRP multiplied by the price that it's traded at. And this is the ecosystem today. So I want to show you just like categories of things that people are kind of like building and coming up with. One is the custody aspect, so wallets. So essentially, I will explain how this works, but in order to interact with any blockchain, you will need to keep your secret key, right? This is like your password. So that is one of the most complicated things for the average person to understand crypto, because they don't work like the same way that your email password works. If you lose your email password, you can always contact like Google or others and reset your password. There are always mechanisms to do that, and it will be up to the email provider to reset the password easily. In a blockchain world, essentially, you cannot do that, and no one can do it. And then if you lose your key, essentially, you lose your funds, because ownership in a blockchain equals to your ability to prove that you are the owner of a secret key, that it's like the cryptographic function, that it's validated by the network, but that it's performed anywhere, but you, as long as you have your secret key. So that creates an opportunity for people to create wallets, to create secure software that either runs in your mobile, typically in your device. So it's something that you download. So it's a native application that kind of like the main goal is to keep as secure as possible the private keys. And sometimes your private key, you not only like keep it safe in like an enclave or encrypted, but sometimes you split. There are mechanisms that use math that essentially like you're able to split like a secret key, and then you can like store that secret key in separate devices, and you can like set up configurations, for example, saying like in order to perform a transaction in the blockchain, I will need like 2 out of 3 signatures, and for example, that means that you can set up in a way your security that it doesn't matter if you lose one of your keys, if you lose one of your devices, you always have a setup that will be resilient in those conditions. So all of that, it's a big vertical that create opportunities for entrepreneurs to create solutions. So all of these wallets and custody services, that's what they do, and that's a big part of you know, some of the biggest challenges in the blockchain world are actually in this category. Then you have infrastructure and tools, which is, we'll be like seeing some of these, but in principle, blockchain in general, there are a few exceptions, but in general, they are public. So it means that anyone with access to the network can go and see and browse what's happening. So that doesn't mean that it's easy to see it, right? Because you would need to have a connection, and you would need to have a way to index those transactions. So the opportunity that many businesses have seen, which is like, I would say this happens in phase 1, is to make it easier for the average person to understand which transactions took place, what's the status, so that you can have user-friendly interfaces where you can like see all the different transactions. So that's also a big category, which is important, especially now. So you can see if someone uses the blockchain to represent like their own token. For example, if some communities, they sometimes have their own token and they use the blockchain. I mean, what they want is, instead of using the native token of the blockchain, they decide, oh no, what we want is a community token, so that, for example, we can do voting. So you can use a blockchain to mint your community token, but also you need a bunch of tools so that you can like see who is holding your community token, so that, for example, if you are implementing applications that have voting capabilities, depending on how many tokens you have, that depends on that, how much voting power you have. Those are like things that people typically talk about in the context of DAOs. So DAOs are decentralized organizations that typically use these type of fungible tokens to determine who has, like, for example, voting power, and they typically use these things to help to have different forms of governance to take decisions in those specific organizations. There are marketplaces that this is also something that it's very important now that you have the ability to create assets that are like auditable, that are transparent, easy to transfer without intermediaries. So now you kind of like need a place where you can trade, right? So exchanges are a big portion of the applications, kind of like Coinbase. What they do, they're not a decentralized exchange, but they're an exchange. What they do, and really they're getting money from really the need of people having to exchange some tokens for another type of tokens. So marketplaces are a big part of the blockchain world, and it can be, again, something like Forex, like just for fungible tokens, or it can be marketplaces where people trade NFTs that we will be talking more about, but NFTs for other type of tokens. And then probably you realize that the blockchain world is kind of like isolated. It's not that your bank can give you access to the blockchain world. So it emerged as a parallel financial system, but then some people still need to bridge money from the traditional world, meaning your bank, and convert it into crypto, and that also creates a different opportunity. This is a very highly regulated vertical in the blockchain world, but on ramps and off ramps are really something that today they're badly needed, because the majority of the people, they earn money, they get a salary in dollars, but they also have the need to participate in this like decentralized finance world. So they would have to have like an on-ramp for crypto. So these on-ramp companies, what they do is they have a money transmission license, and they will like essentially take the money from someone, and they will go maybe to one of the exchanges. They will make a trade on your behalf, and then they will like give to you like the asset that you're looking for, or that you need for other purposes. And then there are like other people that see, okay, there are like fragmentation in the blockchain world, so they're trying to just make it more interoperable. And this is something that it's one of the latest trends. Okay, there are several blockchains that are targeting and serving different needs. So now what we need, interoperability. And that represents a bunch of different challenges, but there's also a good amount of companies that are using different technologies to make it easier to jump and to go from one blockchain to another. So before going into technicalities, I want to make a quick stop and see if like there are any questions about any of the things that I talked about.
XRP Ledger question. Why is it that gas price is just too expensive? But how did the RippleX created XRP to be such cost effective?
Yeah, I think that's a great question. I'm going to repeat it just in case, because we're recording this. So the question is, why when you do a transaction on Ethereum, it costs a lot of money, and in the case of XRP Ledger, it doesn't. And what are like the things behind the scenes? So the kind of like the way that there are like a couple of things to look at where the transaction cost comes from. One is, if you see what Ethereum is, it's like an auction system that it's auctioning like block space. So anyone that wants to create a transaction in the network will have to get a little space in the block that each block, in the case of Ethereum, it may be created every minute or so. So depending on the amount of people that are trying to embed their transaction, kind of like an auction starts to take place. So there's a clear mechanism where like obviously the more demand, that's why, like, for example, when CryptoKitties, which is an NFT that got really popular in the game, people wanted to do transaction on Ethereum. So because they really had a financial incentive to do it. So the network itself, because they cannot create more block space and more transactions, that's kind of like limited. So what it happens is that they have a mechanism in which like the fee increases, right? So that's one thing. And the other aspect, which, because some people are familiar with this like dynamic mechanisms of fees, and in a way, XRP Ledger also has a dynamic fee. It doesn't work the same way, and this is like why the second point is important. Is the other thing to consider is where the money goes to, right? In the case of blockchains, like, for example, where the nodes that are validating the transactions get paid. Think of like in proof of stake systems, and if it doesn't make sense right now, those terms, we will explain a little bit as in later in the technicalities, but there are different ways in which these validator nodes are organized. And one of them, for example, it's proof of stake, that in a way it's a mechanism to allow some of these nodes to participate in the creation of blocks. So let's say that not anyone can create a block in a blockchain. So you need to have a criteria on how are you going to let someone to create like the next page in your blockchain book. So what Bitcoin does, it's like they run some kind of lottery. This is what proof of work does, in which like you are exchanging your computing power for lottery tickets that give you the opportunity to be the miner that will be building the next block. And why that is important, why they participate, why they exchange like computing power and their machines, which is electricity that they pay with dollars, is because there's a reward. There's a reward, and the reward comes from fees. So a lot of the blockchains are based on the idea that the transactions are expensive, and the security of those networks are really based on the principle that people are going to be willing to pay for fees, which is controversial, right? Because that means that in order for Bitcoin to be successful, it means that the fee needs to increase a lot. And what does that mean? It means that right now, Bitcoin is a very effective network to move a lot of value, but it's not a good system to move tiny amounts of value. And so it's kind of like weird. It doesn't mean that it's a bad project. It's kind of like the opposite. It's incredibly successful, but it's just like gives you some insight that there are other areas of opportunity that Bitcoin by design cannot cover, right? And one of that it's the low amount transactions. So how does the XRP Ledger works? So they don't pay. So the validators are not paid. And that's like something that it's very unique in the blockchain world, because both Ethereum and Bitcoin behind the scenes, there's someone that to create that block is getting paid. And why on the XRP Ledger, this is actually controversial in a way, but it's good for the user, but it's it looks bad for the validator, right? Because, but the idea is in this session is to talk about this trust model, that how you can rely. It's a very different security model in which you are relying on different things to kind of like make sure that the network is still trustworthy, but that you don't have to pay like a mercenary validator that will not do their job unless they get paid. So the vision behind this mechanism is that the businesses think of an exchange. So an exchange, they will, in a way, they have incentives to participate, to run a validator, because the validator gives you also access to a few things, like for example, how the network evolves. I will talk about like governance, but in general, like you will have other incentives, but they will be not monetary. So it will just, first of all, like help you to guarantee that you will have a direct access to send and receive transactions, and that you will be able to read what is happening without relying on anyone, but also that you will have a seat in the governance, and you will be able to kind of like have a voice when deciding what feature it's added or not to the protocol, to the blockchain. So that but they don't get paid for doing, you know, the work that in other networks they do. But the good thing is that then they're kind of like subsidizing transactions. And then the result is that the end user will have permanent low fees that then allow you to cover other parts of like, let's say, the overall bunch of transactions that are the ones that are low amount transactions. And that's kind of like one of the core ideas why XRP Ledger emerged in the first place.
Yeah, I didn't understand, why does it look bad for the validator to not have a proof of work like for XRPL? Why does it look bad?
So can you repeat like the question?
You said that it do not have the proof of work like Bitcoin,
Yeah,
or XRPL, make it look good for the user, but not for the validator.
okay.
Can you explain what you mean?
Yeah, so I think this is something that is a little bit misunderstood in Bitcoin. People think that anyone running like a Bitcoin node will get paid. And that is not true, right? So but the miners are getting paid. So when Bitcoin was born, there was no difference between a miner and a node, because it was born from the same code. But then, as things evolved, kind of like two different roles emerged. So one is miners who get to create blocks, and we'll talk more about what a block is. And then the nodes that are users that they don't want to trust anyone to validate the transactions themselves, right? So I run a Bitcoin node, which means that I get the full history of transactions in my computer, so it takes days to sync. So you will download the transactions from Genesis, and you will be able to see that every transaction is kind of like linked until like the very first, until like the very beginning of the network, and that gives you the ability to validate yourself the transactions. But that doesn't mean that I can create blocks. There are thousands and thousands of nodes like mine, but people think that because this is very famous, that the other role, the miners, get paid, that it's profitable to participate in the Bitcoin network. Miners, they're more like, they're providing an industrial work. They come, they're not like me. I do it because I kind of like this idea of running my own infrastructure and having like this like self-sovereign way of validating transactions. I'm my own bank. I don't need to rely on anyone to send transactions, to read the state, and that to me is really powerful. But in the case of the miner, it's very different what it happens. So a miner comes only because it's profitable for them to create blocks. So that's like, it's an industrial job that has become a very competitive market of people who are buying ASICs, which is like this single purpose computer that will only work. This is what these like mining machines that are famous in the news, they do. It's like running an algorithm, which is hashing, and essentially they will be rewarded according on the ones who have more power, more hashing power. They will have more, it will be more probable that they will be elected by the network to create a block, and then they will get that reward fee that it's kind of like the deterministic, and it's stipulated in the protocol level. That fee over time, it's gonna decrease. That's what it's famous in Bitcoin, the Bitcoin halving. It's essentially like just every 4 years, that reward like is cut in half. And but because the Bitcoin price has increased, which is needed for this mechanism to work, the miners are, it's still profitable for them. So they are doing an industrial job. And in the future, the question for Bitcoin is like, because this miner fee this miner reward will go away. So you will only have to rely on users paying for transactions, for fee. And that means that users will have to value a lot, like the job that the network is doing for them, because the transactions will be expensive. And this is what today is happening. So creating a transaction on the Bitcoin network is expensive. And in your question is why? So some people think that validating or creating like new pages of the blockchain needs to be rewarded, because that's kind of like what they perceive it happens in other systems. But the reality is that we still see people that are willing to run infrastructure without getting paid. But that's not the case, for example, on systems like Ethereum, that is proof of stake, where essentially people come also because they just want to get paid. And in order to get paid, some of these systems, they create new native tokens, right? So they have inflation because it needs to come from somewhere. So it also dilutes everyone in order to pay for security. So those mechanisms are designed in different ways, but the reality is that if you want to have permanently low fees, one of the solutions is to work in this way, in which like the people who are going to be running infrastructure will not be charging a fee to the one that it's requesting those transactions. Are there any other questions?
So like instead of giving the gas fees, it gives like the voting power. But does that really incentivize validators to validate XRP transactions?
Yeah, so the answer is yeah. I can talk more about like that specific. It's not necessarily the only thing, but I would say it's powerful, because at the end of the day, like, so this type of, and I'll talk more about like how the XRP Ledger works. XRP Ledger works very differently from Ethereum, in a way that Ethereum is kind of like a protocol that people can add features in the form of smart contracts, and they can deploy those smart contracts through like this virtual machine that Ethereum offers, the EVM. But the XRP Ledger kind of like, but that has trade-offs, that has like some downsides, and one is that you will be having a lot of people deploying a lot of contracts. Some of these contracts will like obviously create like a lot of storage needs So it will create a lot of state. The state is the memory of this contract that every contract will be deploying, and you will be growing incredibly in an exponential way, like the resources, right? And the idea of XRP Ledger was like, okay, smart contracts are really cool, but what if instead of like allowing anyone to deploy a contract, and then that has a huge like surface of attack, what if like the best smart contracts, they just get baked into the protocol, but they need to go through a governance so that the users decide which ones get to pass. And I think it's more like a cooperative, more like in that sense, like a consortium model. And then it's really powerful. That's why in this model of blockchain, yeah, I would say the governance is powerful because of that reason. If you would have this smart contract that permissionless in a way that you have zero approvals and no governance mechanism, then yeah, it's not that needed, because kind of like the features maybe that will change, it's not what people want to change in behavior, but this is a little bit different. And it sounds restrictive, but I'll talk more about like what the vision is about to interact with other blockchains, where kind of like the idea is, it's not that the Ethereum model is bad. It's just like I feel that it serves a different purpose from the type of transactions that XRP Ledger, at least the community, is excited about, which is more like transaction based rather than more like computation, right? And one thing that I wanted to say on that point is that if you see how many smart contracts really have got traction, it's low, right? I don't know how familiar are you guys with the DeFi world, but there's a handful of smart contracts that really got traction, right? If you ask someone like on DeFi, what's DeFi, they will like mention like a couple of things, like an AMM, an automated market maker. They will like mention a over collateralized lending protocol like Compound, and a few others, but in reality, after that, there's not much. And the reason is because all of the other things that people have been experimenting with, they have a big reliance on the out world. You know, you will need like these oracles, and then you're bringing data from the off-chain world, but then you're dealing with all of these inefficiencies of the on-chain world. It's like, it kind of like doesn't make a lot of sense. Then at that point, if you're relying on a trusted party outside, why don't you rely on that trusted party to do more of what you're trying to do on-chain? So that reliance on off-chain parties, you don't have it with an AMM. An AMM, it's a very contained, it's a beautiful design, I think, for blockchains, because it allows you to do slow trading in a very efficient way for blockchains. But there are many examples like an AMM, and an AMM, the automated market maker, has been proposed for the XRP Ledger, for example, and that's something that already it's designed, it's audited, and now it went through like this. It's in this voting like process in which like if it passes, essentially it gets baked into the protocol, and instead of like instances of AMMs, like on Ethereum you have Uniswap, but you have like other, you have SushiSwap, and then anyone can, and that creates like segregated liquidity, right? Because you have like, and then you need an aggregator that goes into pools of all of these different things. But the vision is like that, it creates inefficiency. So why not, for example, if an AMM is powerful, so the one that it's getting passed and get it like added to the XRP Ledger, it will provide one service for everybody. And then like it becomes like a commons in a way, and it will be available for anyone to use it, but you will not have like this fragmentation happening. And I think it's just a lean way to do it. I mean, people may argue, yeah, but it's not that profitable, or you cannot innovate. For sure, I think there are arguments to do it. I don't think it's the best of every single world. I just think that there's a space for this type of architecture to serve certain cases where you will feel organizations around it comfortable, like including financial institutions, instead of having to deal with the Uniswap model that they need to understand that there's a native token, Uni, and that you will need it for some transactions, and that also you can exchange, and then you also have like the Uni socks that you will, it's kind of like, it makes it complicated, or it overcomplicates things. And I mean, I'm a big fan of Ethereum as well, but over time, I've seen a lot of barriers for adoption. And one of the reasons is like all of this over complexity that takes place because some of these things, right? So people have extra tokens that they don't actually have a utility, and they have all of these different mechanisms that in a way, like they just damage the user experience. Okay, so I think I probably skip too many things. Is everyone following a little bit the conversation, or should we? I have a few slides to talk about like the because this is supposed to be a one-on-one. I know you're more advanced, but I also have some slides to talk about, like for example, the how a little bit like to give you insights on how the cryptography of these systems work. Do you guys think it's valuable to talk briefly about the asymmetric cryptography of that it's used? Okay, so this is, and feel free to say anything. But what I wanted to say is what. So why this whole space emerged in the first place? It was to disintermediate, right? So that's the whole thing. Before Bitcoin, there was no way in which, like, in a digital form, you could exchange value in the internet. So without someone in the middle being like the one deciding, crediting one end and debiting the other end. So that sounds like not a too bad problem, but it's actually a very crazy thing. So if you think of your bank and you have digital dollars, because people sometimes say, oh, why do I need a blockchain if all of my money in the bank is already digital? And the answer is yeah, but you cannot do anything with that money unless there's that intermediary, which is your bank. Or if it's not your bank, think of when you want to do like a transfer to a different bank. You also need a third party. Think of what Venmo or Zelle, all of these systems, it's the same role. It's the intermediary that will be the authority saying, okay, this transaction is valid or is not valid. So that's at the core why something was needed. And people would say, oh, cryptography it kind of like solves that. And the answer is no, because this is to explain a little bit what the cryptography behind these systems do, and to make you realize that it's not the innovation that the blockchain represents. So what cryptography allows you to do is to create digital signatures. You can think of a digital signature of, so this is what it is. So a digital signature looks like this. It's just a string of bits. But that digital signature, if you can think, what's the utility of it? Think of, it allows you to create like a virtual check. So a virtual check, you can say, Marco is sending money to Alice, and you can do this digital check, which is a message, in which you can say, Marco sends $20 to Alice, and you can create a digital signature that includes that information, right? So think of this digital signature as as something that proves that I'm Marco and that I'm authorizing that $20 of my account gets debited and then credited in a different account, which is also included in the message. So it's magic that someone can receive that message and then can just look at this digital signature and say, oh, actually Marco was able to instruct that transaction because I can validate the digital signature. That's what you can do with that string of bits. You can see that it corresponds to a public key that only someone with a corresponding private key would be able to form. But you don't need that private key in order to verify it. That's why these validators on the blockchain, they can validate signatures without knowing the private key. The only people that hold those private key are the users who are the holders of the assets that live in a particular blockchain. So, but if you think of the message and the digital signature, what it does, it's magic, but you still need someone that authenticates that transaction or that message, and you get to the same problem that you still need that clearing house that is ordering these transactions. You still need like this canonical history of transactions that orders transactions, and that ordering system is what the blockchain provides. So the cryptography itself, it's one of the components that it's used in a blockchain, but it's not the innovation itself. So the innovation itself, it's a way to order those transactions. And that's what Bitcoin did. So what Bitcoin did was ordering transactions. Here is like the list of transactions. And at the end of this list, this is what a block is. It's a list of transactions. And then you will be able to see a hash, which you can think of like a fingerprint of the block that is included in the next block. And in that way, you can link every transaction to the very, very first one transaction that happened on the network. And that ordering of transaction is what the Bitcoin is created to do. So ordering transactions, but not the cryptography, it's what the blockchain it's capable of doing. Is there any questions in this point? So that's clear. So some of the problems of we already talked some of these problems that Bitcoin may have. And again, this is not saying that Bitcoin doesn't work. To me, Bitcoin, it's clearly that the market is saying that Bitcoin is really valuable, but it has some inconveniences, and I want just to give you an accurate view of what are those inconveniences and how other blockchains can fill that gap. And again, with a trade-off. But one of the things is the reorganizations that happen on the Bitcoin network. So that list of transactions that I mentioned, it happens every 10 minutes by design. Some of these miners will win the lottery ticket, and they will be able to create the next block. Each 10 minutes by design, it takes someone to figure out like the next block. And then the only rule to know which transaction is valid in the Bitcoin network is to see which is the longest chain. So the longest chain is a rule, and that's the source of truth for anyone. If you want to see if someone sent you Bitcoin, you will have to look at the longest chain. That means that in parallel, there are other chains that are being created simultaneously that are not as long as the one that is considered truth, which is weird. But sometimes it's because it's redundant. So not only one entity, one miner is trying to create the block. So everyone is trying to create and come up with the next block. And only one will win. But other entities, other miners will be finding blocks that are transactions ordered slightly different, but that they end up creating like alternative paths for the blockchain. And sometimes those alternative paths, they become the longest chain. So it switches sometimes, and that's called a reorganization. And those reorganizations have happened or are actually are common in the Bitcoin network. It's normal. And the only way to solve that problem is to wait. So sometimes when you send Bitcoin to an exchange, essentially you will have to see how many confirmation the transaction has. And that means how many blocks have been created after the block that your transaction was included in. And that, what that tells you is that this is what it's called the probabilistic finality. So you cannot be 100% sure that, it sounds weird, but it's how it is in Bitcoin, that a transaction is final. So that probabilistic finality, it means that if you're an exchange and you receive some Bitcoin as a deposit, you will have a probability of that transaction being final. And then if you wait and you get more confirmations from the network, that probability goes higher up to a point that you say, oh, this Bitcoin definitely is already in my possession, because it's very unlikely and almost impossible, because it's very expensive to create an alternative network, an alternative chain that will like replace the longest chain. And that's how like exchanges mitigate the risk. But sometimes this type of attacks have happened, in which someone is creating an alternative path and it becomes afterwards, after 2 or 3 blocks, the longest chain, and then it reverts all of these transactions that were considered final. And then exchanges, for example, lose a lot of money. So was that clear, that type of attack that can happen in Bitcoin? Because I think it's interesting. People don't talk that a lot, but I think it's one of the things that it was years ago heavily discussed, and it's one of the theoretical attacks that create a lot of inconveniences, but now not a lot of people are familiar with. So the idea of XRP Ledger is to essentially don't have to deal with those reorganization problems. So in order to do that, it completely changed the way that it works. So instead of ordering transactions, it orders accounts. So it orders accounts. All the different wallets that I mentioned are tracked by the ledger. And if there are operations that change the let's say the state, meaning if they change any of the attributes of that specific account, those attributes can be how much XRP it's under the control of that specific account, or other types of assets. Like, for example, as I mentioned, in the XRP Ledger, an account can hold XRP, the native token, but they can also hold another form of token, for example, fiat tokens, and that it's represented using the asset standard that allows you to create fungible tokens. So it creates the same canonical ordering system in the way that Bitcoin does, but it doesn't have like the inconvenience of having this probabilistic finality. And this is what it's called deterministic finality. And financial institutions really like that, because a transaction, either it's complete or it's not complete. So again, you have other trade-offs, but in reality, the idea was to create transactions that were not without ambiguity, saying if you're an exchange or a financial institution, you can be completely sure, 100% sure if the transaction cleared, the transaction took place or not. The trade-off, I would say, it's actually there's a triangle that explains this well. It's liveness of the network. So the Bitcoin network it's like it can fork, right? So like there is an event where let's say and in this type of architecture, it halts. right? It halts. So if there is not like a way to resolve something like that, it just like it will stop, and then you will essentially like be stuck until you have a way to resolve. So that's that's in many ways like how it has materialized, like the trade-off. And the way to think about XRP Ledger, very simply, as I said, is like features or other forms of, features, it's a good word, that have been added to the original features that were payments. So on the top of the ability to do payments using the XRP, the native token, or other forms of token using the standard, the token standard. So you also have the ability to create offers, because now a decentralized exchange, not an AMM, like a traditional, like a normal bid and ask exchange functionality was created where you can like send the same way that you send a payment request to the network, you can create a request that represents the, like the desire to create an offer, for example, to trade one asset for another. Or now the functionality of NFTs got added as well. So that means that you have other transaction types that not only are like the basics ones that allow you to create new fungible tokens, but allow you to mint an NFT or to list that NFT for sale. And coming next, that this one it's up for voting. It's not yet, but the idea is as new features emerge and are kind of like get support and the likes of the community, then more of these will emerge and be available for anyone to use. So the idea for you guys is to just analyze which are the features that are available, so that you can think how to build a product or a service that takes advantage of some of these features, right? So for example, as I said, if you're thinking of a community that has a token, a fungible token that serves a need, you can do that with just the token standard. That in a way it's part of this payment bucket. Or if you have, the idea of providing an interface for people, let's say, to access or to trade Bitcoin for XRP and for other tokens, you can get use of these like order book functionalities that allow you to create offers, bids or asks for any particular asset as well. Or if you're more like Web3 oriented, you will be able to mint or trade NFTs. All of that can be accessed through an SDK. This is like, instead of like, there are typically one of the reasons why not a lot of developers are interested in the blockchain world is that sometimes getting started is complicated, especially in the Ethereum world, because as I mentioned, the smart contracts are this like complex layer that sometimes is not very friendly, where people need to think of features that the blockchain needs, and then they deploy the smart contract. And then they also need to figure out how to, through libraries, access the methods of those or functions of those smart contracts. So it adds layers and layers of complexity that sometimes it's really hard to start working with. In the case of XRP Ledger, everything is abstracted away with the SDKs. So if you have, for example, experience with JavaScript or with Python or Java, you will be able to get access to all of the different functions that these features offer in a friendly way, that you will be able to just import a library, and that library will have a method that will allow you to access those features. So I'll explain a little bit more in the next slides, like how does that look. but I'm also happy to walk you through some code either in this session or in the next one. Are there any questions so far? No? Okay, so this is just an example of a cycle of a transaction that it's important to talk so that we can like just see as a whole, what does it mean to do a transaction on the XRP ledger is through these SDKs. Essentially, you will be importing, this is JavaScript, but the same thing goes for Python or Java. You will have to import a library, and then you will be creating an async function in which you will have like 4 steps. One, there's a way that you will open the connection with the network. Like this is because the way that this SDK connects to the network is using WebSockets, so that it's abstracted away by the library, but in principle, you will open a connection. So essentially, it creates a connection, a bi-directional connection that allows you to send messages back and forth. The application needs to prepare the transaction that they want to perform on the ledger. Like let's say that you want to make an XRP payment, you will have to prepare an object that includes like a signature that you will pass through that connection that you open, and you will be sending that to the ledger so that it's validated through this like decentralized system. You will be sending that through something that it's submit and await. Just again, a combination of two things. One is submitting and then is waiting for the response. And then after the response, either it takes place, it succeeds, or it doesn't. And then you, with a line of code, you disconnect, and that's the cycle of. And every single thing that you can do in the ledger, it doesn't matter if it's creating an NFT or if it's like sending XRP to someone, everything follows like the same pattern. So essentially, you will need only one asynchronous function that will allow you to perform any of the things that the ledger allows. Is there any question? For those who maybe are more business than computer science, please bear with me. This is not, the idea is for this to not be complicated. It's just the idea to show how simple and basic like the set of steps is. Do you guys in general, are you familiar with Python or JavaScript? I would love to hear. Okay, Python.
Yep, JavaScript, Python too.
Both. Okay.
I'm not lost.
Okay, but you're still following the well, but okay, then it's not important. Python. Okay. Oh yeah, just yeah. Well, I can also afterwards I can send you, for example, a script so that you can run a Python script and you can like see all of the different steps that does the same thing. But again, it will connect you in like the first step. Then you will be creating an object like this. This is a JSON object in which obviously you will have to include those things that the network will require. Think of if you're doing an XRP payment, essentially the network, think of the network like these validators, what can they do to validate that the transaction of sending XRP requires? One is like what type of transaction it is. The other is like what's the destination, and then what's the amount, and who is the one that is sending the money. And then obviously you will need like after this to sign, meaning that you will need to prove that you are the owner of this account. so that someone can check the instructions and can also check. I mean, when I say someone, is essentially the mechanism that it's what consensus do. It's like the different validators of the network. They do all of these checks, and once that they agree that, yeah, this is valid, this person is authorized to send that transaction because it proved that they were the owners of that specific account, then they agree that it's a valid transaction, and then it takes place. And then you will be submitting the transaction by sending the signed transaction, which is like the thing that I'm passing to the submit and await method, and that's it. So to not to keep it very technical, I'm just gonna be talking one more little topic about what the XRP Ledger is kind of like pursuing in terms of interoperability and in terms of like growing in the future without changing like the core fundamentals that I've described. And this is what the sidechain initiative is, which is there are other systems very different from XRP Ledger that are very different. There are multiple blockchains that work with very different assumptions. And the goal is to, and some developers really like other ways to develop, including like the Ethereum virtual machine. So the idea of XRP Ledger right now, and a lot of people are working on this, is to be able to interact with a bunch of other chains that are around like the main chain, and that are able to send and receive assets in a way that does not sacrifice security. So think of XRP Ledger, and then now there's kind of like a realization that some of the applications that started as smart contracts on Ethereum, or that started as centralized systems, there's the realization that some of them, they actually want to become app chains, meaning that they really want to be a chain by themselves, but also they want to be part of an ecosystem. As I said, like some of these chains have a lot of holders and a lot of like loyal community members that they really like the idea of transforming financial services, but some of the things are not still, it's too restrictive, the ledger. So the idea is how can we expand the possibilities by interacting better with different forms of chains? And that's the idea behind sidechains. So right now in the works, in a full testnet, live on testnet, there's an EVM compatible chain, which is a separate chain that it's kind of like similar to Ethereum, but with the ability that it connects through a token bridge to the XRP Ledger. So people can, and not only that, that Ethereum virtual machine compatible chain will also accept to pay fees in XRP. So if people build applications that are like DeFi apps, so you will be able to pay with XRP the fee for those transactions. And that XRP is the same XRP that needs to come from the original XRP, which only exists on the mainnet. And the bridge, what it does, it observes the two chains and will only move XRP to this chain as long as this one is locked in one new type of account that it's called a DOR account. So that innovation, which is a secure bridge, is what enables this type of architecture that a lot of apps are looking into as a way to expand the possibilities of the XRP Ledger. And again, this is not important, but I just want you to give you an overview of what expansion means, which is not always in the way that it's expected. Right now, there's a lot of like projects that are building around the XRP Ledger in ways that they only use the bridge, other than that, they don't touch or try to modify the behavior of the original chain. And in a way, these protocols become to ossify and become like less, more predictive, but more difficult to change. So if someone here has already experience with Ethereum in the past or with an EVM chain, so I encourage you to go and try this one out. I will be sharing like this information, which essentially it's just the only information that you need to point to this chain, so that you can, for example, if you have MetaMask, you will be able to redirect your MetaMask using like this RPC link, this RPC endpoint, that by doing it, you will be able to talk to this chain include with any of the existing infrastructure that allows you to interact with Ethereum or any other EVM chain. And you will be able, through a faucet, just get test XRP on this chain as well, or in the main chain, and you will be able to bridge it. All of that is functional on testnet and allows you to experiment with it. So what I wanted to give this overview for is to help you understand that the way that people are prototyping solutions on the XRP Ledger is not only by taking advantage of the main features, but there are projects that are thinking, okay, maybe I want to build a smart contract that lives on this separate chain, but that is kind of like related or trying to be part of like the same ecosystem that it's interested in financial services and the financial industry. So these are like the two options that again I see as a way for you today to prototype a thing. So these workshops, the idea is to start ideating solutions that can improve the world, but taking advantage of some of these technologies. And as of now, either you can think of a financial application that uses the XRP mainnet. It's it has a set of features that are already available for you. You can only go, I mean, you not only have the testnet, but you also have mainnet and a bunch of users, or you can also experiment with the EVM sidechain in the case that you want to help also build this ecosystem or of EVM compatible chain that it's also aligned in vision with transforming the financial services. And the way to communicate, which I think this is important, is through Discord. I think this is the best way, and I'm happy to create a channel if it's needed. But this Discord, XRPL EVM, well, that's specifically for the EVM. I think we have a different one, which is XRPL devs. I'll send you over the chat like the link of this other one, but I'm happy to adapt to a channel in which we can help me and the other developer advocates, so we can like help either kind of like replying to questions, if there are specific questions about ideas that you want to build, propose. The goal for us is to help not only answering those questions, but also understanding what are like the features or the ideas or the solutions that you really want to use the ledger for, and in which ways like you feel limited or you feel restricted, so that we can take into account those type of problems that you want to solve, and eventually like take those notes to engineers that today are working on like the roadmap of things that they want to add to the ledger. So do you guys use Discord, or what's the more like friendly way to communicate? Okay. So here, I want to do two things. One is like Q&A that we've been doing. And then I would love to switch the roles and kind of like hear what are things that you would be interested in building, so that we can figure out or discuss how we could potentially either help form teams or kind of like guide this journey to from understanding how the ledger works to be able to up to the point where you can as well propose the idea, and we can help with either finding team members or directly like sending over resources and documentation. So anyone has a question first?
You also take your slides.
Yeah.
Those one again. Yeah. Can you explain what is the difference between proof of association consensus and proof of authority?
Yeah. So essentially the proof of association, it's I'm going to try to explain this in a simple way. So the way that the consensus works, which is how you get to have all of these validators agreeing to this particular set of transactions that are valid and that they will be applying. You will have to form a mesh. You will have to form a connection between those validators. And right now, the way that you establish like a map of trust is with this proof of association. And the way that it works is every validator in their configuration, it stipulates for that particular entity that is running the node, who are other nodes that are trustworthy, right? So think of like now network of 30 nodes, and each of them, you have a configuration file where you will be pointing to those other validators that you consider trustworthy. Think of, this is not something that is run by banks, but think of a network of banks, right? So maybe you are a bank and you trust other two banks. So you are going to be running this code, and you will be adding the names of or the addresses of the nodes of the entities you kind of like trust already, but that's it, not more. And then other banks will be doing the same, and some of these will overlap, right? And that is what the proof of association, it kind of like it's based upon. It's the idea of creating this map of trust by just leveraging these connections that are expressed by each of these nodes, establishing a trust relationship that if you aggregate all of them, you form a quorum where you can like make sure that the majority of the people that trust each other are in a single agreement for a particular set of transactions. So that's the proof of association. The proof, and there's a paper that talks about like sometimes it's called XRPL consensus. The EVM sidechain is not copying that model, and it's based on a simpler way to reach consensus, which is called POA, or proof of authority, which in principle is just a list of nodes that are forming like the trusted list of validators, that they will be the only ones that are going to be creating blocks, right? And in order for you to add a node to the list, so all of the nodes will have to agree, and they will have to adopt like a new member to the list, so that it can expand that list into and in a way that it's create like, oh, proof of authority means that, okay, so that authority, that sometimes there's a governance, but again, there's a group that represent that authority, either expands by adding a new member, or the other way around, by expelling a new member, it reduces to a different size of authority. So those are different configurations. Obviously, like some of them are more closed access, some of them are more open access, but in a way, like they try to achieve a similar thing. It's trying to create a group or a committee that will be agreeing on the changes or in the state of transactions.
Is Ripple the only like blockchain that's using like our RPCA? And another question I have is like, what are some of the apps that were very successful built on top of the XRP Ledger?
Yeah. Well, I mean, I can, for example, one that it's very not financial related. For example, there's an NFT marketplace, but now it actually started not a long ago because the NFT feature was added, if I remember correctly, like 2 years ago, and one marketplace already taken advantage of those features called XRP Cafe, is already like having like a bunch of users from a lot of countries that are trading, creators, NFTs. All of them use like the same standard, the NFT standard. That's just one example of a very like indie project that was created by maybe 2 or 3 people, one developer, or maybe one creator, one social, and kind of like reach a good number of usage and volume in a short period of time. There are also other projects that are more, I would say, more related to, yeah, like the usage of XRP, right? Like, for example, like one example is I remember back in the days, like Bitso, the most successful exchange in Mexico, because I'm originally from Mexico. One of the things that Bitso did in the very beginning was kind of like helping people to move money abroad by enabling XRP, right? So at that time, people was like frustrated by having to wait time for Bitcoin to be credited in their accounts. So they were not able to move fast transactions from the US, for example, to Mexico. So XRP kind of like the goal there, people were not like speculating on XRP as much as they were transferring value, because it was the easiest and fastest way to go in and out of exchanges. So there was a lot of emphasis about XRP, and a lot of the community grew because people like realized they were able to go in and out of exchanges very fast, which maybe right now there's other tokens that allow you that, but that also was kind of like in my opinion, one use case that resonated really well, because the people were not trading or anything like that. They just needed a fast way to move money from one country to another. And again, there are other like applications that are more like just interfaces. One, for example, like Sologenic, it's an interface to the DEX, to the decentralized exchange, where you can, if you see the interface, it looks like the traditional, like Bitstamp, like the traditional order book exchange. But in the let's say the behind the scenes of Sologenic is just the XRPL Ledger order book, which is, it's incredible, right? So instead of like building your own order book, I think that idea for me is really powerful, is that you can take advantage of an existing order book that actually lives on chain. It's auditable. So right now in exchange, you don't know really which transaction takes place, if like it worked correctly. So you have all of that execution, and also like you can set up an exchange. If you're not, obviously, like there are trade-offs, which is you cannot like add maybe a fee or something like this in a way that maybe in the way you want. But the other side of that is that you will be able to quickly iterate and prototype like an exchange without having to build like an engine, right? So the way that I see the future for fintech is like that. is like right now, if you are a fintech entrepreneur, you really need a lot of money in order to get your own licenses, in order to get a big group, to get lawyers. The way that I see these type of technologies in the future offering to a new generation of fintech entrepreneurs is leverage, right? It's like a lot of the things that you had to build in the previous era, they will be offered in a way by these commons, and you will be able to maybe focus on audiences. There will be maybe in a way more competition, but you will have less monopolies, but at the same time you will maybe have other like value added services that are really important, and not necessarily people taking fees on the layers that make no sense. Like right now, banks, they charge for, I mean, if you see how a bank makes money, sometimes it's ridiculous. It's like overdraft fees, transfer fees. I just want really that world to go away as soon as possible, because I think it will be more interesting that, you know, maybe a next generation of financial services can make money by really adding value to your life and not really trying to just extract value from you when you're not paying attention, which is sometimes how it feels.
Like, yeah, there's XRP native tokens and XRP gas tokens. Like,
yeah, this is terms that actually have been changing some, but this is just to represent the idea that all of the fees of the gas in that EVM compatible chain are paid on XRP, but it's not native in a way that people consider, oh, the main XRP only lives here. But it's similar to the idea of Bitcoin, the original and the real Bitcoin only lives on Bitcoin, but that does not prevent the fact that people will build other layer 1, 2, 3, like Lightning, there's Bitcoin moving there, but that maps one-to-one to Bitcoin that it's on the mainnet. The same thing goes for here. So that gas token, that will map one-to-one to XRP, that it's accounted in those like door accounts that I mentioned, but it will still be called XRP, although right now people are saying, oh, it's not the same as XRP because the XRP can only live on the other chain. So now I think the kind of like the people are going for EXRP.
Are there any specifically any good projects on Ripple which are building something related to people? Physical infrastructure?
To like, for example, you mean to what kind of infrastructure?
There are projects like Hypemapper, Helium, which are built from high field. Ripple is focusing on that field.
Like which ones?
Hypemapper, Helium,
Oh,
those are decentralized.
yeah. Not now. Honestly, I think that's a super interesting area to decentralize, for example, what Helium is doing, which is trying to decentralize like ISPs, and I think that's a fascinating area. I think people have tried in the past. It's just, I mean, in these like more than 10 years, people have for sure tried, but some of the elements were not ready. I think that people are seeing that, yes, having a token, having some things are good for those things, but they're not like the entire solution, which I think it's a good segue to a discussion that we wanted to have here, is like, do you feel like at the core of Helium is really what is really taken advantage of? Because in a way, it feels sometimes that it's either inspired by blockchain, but not necessarily like, for example, taking advantage of something directly that it's offered by Solana, right? Which is like, I don't know. I would love to hear your take. How do you see these projects taking advantage of blockchain, and what is actually needed for those to succeed?
Yeah, I think most of these projects where the blockchain use, they have at least advertises more in terms of micropayments. So if there is a
Right.
network of people and they're automatically paid, even if they're small payments. I think that's one point there. A lot of these decentralized networks advertise about some of the.
That's a great point. I've seen in the past people trying to, for example, when creating a mesh network with routers, for example, but that is paid instead of like right now it's all subsidized, right? So it's like you need to have someone that creates for free instead of like the end user doing a micropayment for, let's say, for renting the infrastructure that someone is using. I think my realization is that so far, the technology that blockchain offers has been limiting, right? Especially people were trying to use this with volatile tokens. That's not possible. So I saw a lot of people, okay, when stable coins emerged, like really for good, which is 2017. So before that, there was no reliable stable coin, which is another thing. So all of these early years where people tried, even those ideas didn't work because when you try to do that with XRP, it doesn't matter if it's fast or very cheap to transact, it's volatile, it just kills the model, right? So right now, we're starting to get to a point where that problem of micropayments, I think is really interesting, right? So there are a lot of people that are excited about using even payment channels, which is one of the native features in which like, obviously a payment channel is limiting because it's only among two parties. But you can start like seeing how certain features can be used to prototype type of solutions where you can transact securely very tiny amounts that allow you, for example, for the pay of physical infrastructure or renting things like in the past were not possible. Unfortunately, today I haven't seen a project that today is trying to solve the problem. I think these type of projects come and go, unfortunately, but I would love, if Helium succeeds, I really would love to see like some other projects trying to do the same thing in these chains that sometimes they're more efficient for certain type of payments. I'm going to stop the recording here and we can continue the brainstorm and see like what other ideas we can come up with in this group and how we can help pursuing like the prototyping of those.